Hi, everyone. Thank you for joining us today for our Investigating Simple Harmonic Motion webinar. So today's agenda, I'm going to introduce you to your presenters here in a moment. There's going to be an introduction to Graphical Analysis Pro and our GoDirect sensors that Dave will go over. And we'll be doing the Simple Harmonic Motion Lab and the Energy and Simple Harmonic Motion Lab from our Physics with Vernier book. And again, Q&A is definitely suggested. So Dave, meet Dave. He is the founder of Vernier. He has 12 years of experience teaching high school physics and physical science. And he founded the company with his wife, Christine, 40 years ago. And helping to answer questions is Fran Poudry. She is our director of physics. She has over 20 years of experience teaching high school physics, and she taught at various levels from conceptual physics to AP Physics C. So again, ask questions away. Fran and I will be monitoring those, and we'll get back to you if we happen to not get to that. Get the answer to your question. And then Dave's going to be talking more about graphical analysis, and I'll be sharing a link of where to find that on our website if you want to download it. So take it away, Dave.
Hi, I'm glad you're here, and I want to thank Angie for setting this up, and also Fran for helping. Fran is a very experienced physics teacher, but she also this time is going to play the role of the student. She's not even in the room with me, and she could be anywhere in the world. Doing what she's doing. The fact that we have the same shirt on, it probably is a tip-off that she's not too far away. Anyway, I'm mostly here to show you the features of Graphical Analysis Pro and show a little experiment. And I'm really excited about this data sharing feature. So that's what we're going to stress. I'm an old guy and I can't resist telling the history of graphical analysis. I wrote the first version in 1981, really. And we shipped it in 82. And it was meant, in those days, it was just for graphing because I was totally into labs and my kids were good at doing labs, but they weren't great at graphing. And I just was so frustrated that they were so clunky and slow doing graphs. And by the time they got the graph done, they had forgotten the physics, the whole experiment. So that's why the program started. It's amazing to me that 40 years later, we still have graphical analysis. And now it's very much a data collection program. And the neat thing about it is it works on Mac, Windows, iOS, Android, and even Chromebooks. So when the Chromebooks, as you know, are taking over the world, sort of, it seems like. So anyway, Angie, next slide there, please. So we're going to use graphical analysis. There's a free version. You can get it for all those devices. And then there's a pro version, and you can upgrade it. And it's a school-wide site license. And we're very proud of that because we think first of all, it's not too expensive. $99 for schools, less than 100 students, $149 for larger high schools or middle schools. And that's every student and every teacher and every teacher's computer at home and every student's cell phone and all those things. And you don't have to be counting students and doing a lot of record keeping to keep the license going. It's a one-year license. So. And we'll show you how to upgrade from the free version, which you can download anytime. Anybody can download, your students can download it. And then we'll show you how to upgrade those. And you do that with a key that your school would normally have one that covers the whole school. In this case, we're going to give you a special key that you can use for the next 3 weeks or so. Next slide, please. So this lab, there's really two labs, Lab 15 and Lab 17 in this Physics with Vernier book. This might not be the latest version, but most of you probably use electronic versions anyway these days. The lab is two labs on simple harmonic motion. And the neat thing about our electronic versions of the books is they have different versions of the lab. I'm going to use the version using our GDX sensors. This is the GDX GoDirect motion sensor, but there's a version using a lab question. There's a version using Logger Pro even, and there's even a version using TI calculators. So, but we're going to concentrate on the new stuff, Graphical Analysis Pro and the GoDirect motion sensor. Next slide there, Angie. The motion sensor is really pretty cool. We have the whole family now has about 45 different sensors. They all connect by Bluetooth or USB. They all have rechargeable batteries. You charge them through the USB cable, but you can also use the USB cable to make the connection to a computer if your computer or Chromebook has a USB port. This one measures sound, measured distance by taking sound waves and shooting them out and measuring how long they take to bounce back, like motion detectors always have. And this is a very useful probe that's used in really literally dozens of different labs in different subject areas. Okay, next slide there, Angie. I guess I'm done and I'm ready to present, huh? So let me do that. Is that working?
Yep.
Okay, good. Now this is a little complicated what we're doing here. Let me try to square things away just a bit. We're going to try to show two things at once. On the left side of my screen, I'm showing my view of my version of Graphical Analysis Pro. And what we've got here is I've got the motion detector. I think it's already connected. Let's see if it is. I might have to reconnect. Let's just do that. I'll say, I'm going to turn this guy on and maybe it's ready to go. I don't remember. No, I guess not. It might have gone to sleep. I'm going to say new experiment, sensor data collection. And if I do collect, we're reading the distance from this motion detector down here to that object there. Obviously, we're going to study that in the experiment. So that's Graphical Analysis Pro, but actually that would work just like it did even if you had the free version of Graphical Analysis. And we'll talk about that update. In fact, what we would like to have you do, if you could, is join in a data sharing session. And so you get the data as I do this experiment. To do that, you need the Pro version. And I'm going to have my student, Fran, show you how to do that. She's the student, and here's her iPad. Yep. And Fran, if you will, can you see? Do that just a
yeah, I can see it, sure. So what I need to do is tap on the three dots up in the upper right corner up here. And that gives me this little menu about presentation, user manual, and what's new. And I'm going to tap on about, and this is where I can put in the key. So there's, we'll put the key in the chat as well. Let me just do that. So that's the key that I'm going to be putting in here, and it's a capital J, lowercase I. I think that's a 0, and then lowercase t, capital A, capital W, 6, and then capital J, capital D. And when I submit that, then that transfers to showing me, all right, I've got this subscription that's going to end on Monday, August 30th. So you should have that same subscription too, so you can play with this until August 30th. And now I can X out of this. And now you can see at the bottom, it actually says down there in the red bar that Vernier Graphical Analysis Pro access expires in 13 days. I'm actually going to X that out because I'm not really interested in seeing that. But now Dave is going to be able to share his data with me and with anybody else who has the Pro version and the code that he's going to give.
Right, so that was great. And you could do that at home. I encourage you to do it if you can right now. Or if you're watching the video, the tape version of this, we'll have to work out the key thing if time has passed, but we'll get you a trial version and you can try it. Anyway, here's the deal. Let's say now I'm the teacher. Fran's got her version updated. I want to teach her this stuff about simple harmonic motion. We're going to do lab 15. It's about the world's simplest lab. We're just going to study the oscillation of this mass on a spring and look at the features of things like period and frequency and amplitude. So here's what I would do. I want to start a data sharing session. This icon right here is meant to indicate something like, people call it Star Fighter, Star Wars Fighter. To me, it looks like radio wave. But if you click on that, it says start data sharing. I want to start a session. I'm the teacher, and I'm going to offer this code right here which I'm making bigger, to my students. Now, let's say we're doing this remotely. You can type in that number, but here's what you do. Fran, show them the method of entering that.
All right, so I'm going to, I put tapped up here on this little untitled, it's got a thing that looks like a piece of paper that's dog-eared in one corner, and click new experiment. And then I'm going to choose the middle option, which is data sharing, to connect to LabQuest, LoggerPro, or Graphical Analysis source. And so now I'm going to have to enter the source ID right here. And so this is where I take what is on Dave's screen and put it in mine. So I'm going to type the RAM, and then I've got a 7, and then I've got MW, and then click connect. And when I hit connect, now I get the same data on my screen that Dave has on his.
So that's kind of magical, but notice that it's not just that she got the old data. It's also true that if I really start to do the experiment, and remember, it's a simple experiment, it just asks us to get this string oscillating and hit collect and take new data. And so you see it's happening on I got the data, but she did too. And remember, she could be anywhere in the world. Another thing I want to add here, you might be saying, oh my God, there's a lot of codes you got to enter. Remember that first code, you do it one time when you first get the subscription. Shouldn't have to do it for another year. The truth is, once in a while, things get disconnected, but mostly you do it only when you sign up on a new device or something. The other code is per session, or when the teacher gets the group together, and that is simpler to enter. We got kept that one all lowercase. Anyway, so now we might, let's say we're in a remote teaching situation, or Fran's a sick student and couldn't come to class today. I want her to sort of have the experience of doing this experiment, but she can't get the data. So I could say, Fran, read over your lab 15 and you'll see that in this lab, you're supposed to do things like, well, first of all, let me zoom in here. Oh, I zoomed in, okay. And now the lab asks you to do things like determine the amplitude. Well, you can do that, and you can do statistics and get statistics. Notice what I did not appear on Fran's. So unless she's really fast at writing down these numbers, she has to do the work, because I got the minimum and maximum, but she has to do that herself. And similarly in this lab, it asks you to do things like find the period, the time from there to there, say. So you read those times off and do the math to get the period, and then they ask you to do the frequency. So there's some exercises there that Fran could do, even though she's not here today, and or if you're in remote teaching situation, this could work. Really, this lab 15, there's not much more to it. They have you repeat the lab with a higher amplitude, and then they have you repeat it by adding another 100 grams to get a different mass. And they're trying to get the point that the basic shape of the wave doesn't change, but the little details change. So that's lab 15. I'm going to rush on to lab 17. Remember, you have both of these and in teacher's guides in your package that Angie's going to get you. Lab 17 is almost the same thing, except it takes and goes to investigate the energy of the simple harmonic motion, and it gets a little more complex. So to do that lab, you basically have the same setup. I'm going to do new experiment. And there's 3 parts to this lab. The first one is the same exactly. And I'll just do it. I collect data. And they just kind of get you used to it again. But this time we're going to investigate energies, and we're going to be interested in how much potential energy and kinetic energy and stuff like that there is. So I will be doing a little bit more. One of the things we want to do is we want to zero the motion detector. So I got it stopped, pretty close to stop, and I'm going to come down here, and if I click right there in the word position, you notice that there's a 0. I click that, and now if I collect data, we're centered on that 0 point. So we get a graph like that. It's almost the same thing, we just shifted to 0. And this lets us get a measure of potential energy. Fran's got it over there too on her. Anyway, now to do the lab, we want to investigate kinetic energy and potential energy. And if you've done any physics, you know that for potential energy, we need the spring constant. So in part 2 of this lab, they ask you to get out your mass set and to investigate the spring constant. And you do that, of course, by hanging different masses on this spring and seeing how far the spring stretches. And we could do that right now, but I'm going to take this opportunity to show you another feature of Graphical Analysis Pro that I think is pretty cool. We did this in the panic to get ready for get you guys through the pandemic. But here's the way it works. We have a video version of this lab on our website. And so if I have the pro version, I can go like this, new experiment. Don't say what I have. And normally we choose one of these 3 things and start a new experiment. But here's another option. These are experiments that we recorded and have data for. And there's a bunch of them. Chemistry, biology, physics, middle school. I'm going to filter to say just I want physics. And I happen to know that this is lab 17, part 2. And right there it is. So I'm going to run this canned experiment that we did because it shows the feature and it saves us a little time. If I make this bigger, maybe not.
Dave, I think you have to, yeah.
I'll just get rid of the graphs. I don't need them. Well, I'll at least show you the video first and then I'll show you the graph. Here's the video we made. You'll see there's the motion detector. This is a wire basket. We have you as a caution, put that there to keep things from falling on, breaking the motion detector when they fall off. See, I'm hanging different masses here and you'll see the things hangs down further. This is like a time-lapse video. And you're getting data. You can even have students write this down if you want, but I've actually recorded it for them. So that if I put the graph back, you've got a graph showing, in this case, position versus weight. Now that's interesting, position versus weight. If I get the slope of that, it won't be the spring constant because the spring constant should be force versus distance. So I'm going to actually switch the direction, switch the axes here and make this one be position and this one be weight. And now I can do a slope of that under here, apply curve fit linear. And now I have, I had apply curve fit. Let me get rid of that video so there's no room. Oops, sorry. Yeah. Now I think you can see I've got the slope of that's just Hooke's law we just did in a video. Now, of course, you can have your students do that, but I rushed through it to save some time and show you that feature. The slope is about 15.82, which we're going to need a little bit later. Now, that's the rush through second part of lab 17. And the third part is probably the most interesting. And in that one, we're going to actually take data with this thing and try to calculate the potential and kinetic energies and compare them. So I'm going to do a new experiment one more time. Don't save that. This time I want data, sensor data collection. I think it will remember that I had this motion detector. I don't have to tell it what I'm collecting. So now I'm back here. I'm going to do that zeroing again because I want this. I want the distance we've moved from equilibrium, and I'm going to take some data. You know, I think I remember something now about the lab. I think it asked me to speed up the data collection to 50 times a second. So I think I'll do that again. Although that was fine, but maybe it'll give us more detail. Now I'll zoom in. Look, it looks like good data. And now the challenge is to, okay, that's position versus time. I can deal with that, but wouldn't it be nice if we had potential energy versus time? And here's how you do that. And this is also explained very nicely in the student write-up. But you go into here, and I'm going to display a data table. And on the data table, you do potential energy from position. So I want to come in here, and I want to add a calculated column based on position. And the form of it is those of you who are physics people know that it's 1/2 kx squared. So it's kind of like that expression right there. And then if I use that form, 1/2 kx squared, the first factor is 1/2 of our spring constant. So that's 1/2 of 15.8, if I remember correctly. So that's 7.9, huh? I can actually put it in. You can actually write it. I'm pretty sure you can do this. 0.5 times 15.8 for that expression. And for position,
Dave, I think you need a multiplier in there.
do I? I don't see my x squared thing here. Did I choose the wrong one?
No, in parameter A, you got 0.5158 and you need 0.5 times the 15.8.
I think it was, wasn't it 15 point? So you're saying, wait, 0.5 times is what you're saying?
Yeah, you were missing the
It doesn't
times.
type. So I'm gonna, maybe I am not allowed to do that. I thought I could. I must start this over. We do new. I'll start here because I got where I was. Add a calculate column. I want to make sure I get that right expression. A x to the b. Yep. Parameter A. Well, let's put the half of k, which is 7.9. I think we said.
Mhm.
And
then you're gonna have to scroll because it's just
yeah,
not
I can't
wide
quite
enough
see
here.
that.
So not the scroll sideways.
Okay. The small screen, we're trying to squeeze a lot on the screen here, and it's hard to see. Position, one more time, sorry.
Mm-hmm.
Oh, here we go. Now can I see?
No.
Yeah, I've
there
got
you
the
go.
two. Okay, good. 7.9 times position, and then I have to scroll over to put the 2 there. So now we have 1/2 kx squared, and we apply that, and now that's a new calculated column, which is, I'll zoom in on it, potential energy. Interesting. Potential energy increases 2 times when you're going up and when you're going down. That's good. Now we can do a similar thing on HRF time on kinetic energy. Now, how do we do kinetic energy? Well, kinetic energy is based off of velocity, right? So let's go to velocity and do calculated column. Let's call this KE. I should have put joules in there. I didn't probably label that last one properly. But this is 1/2 of our mass. What is that mass? Oh, that looks like the thing itself weighs 50 grams and those other things are 50 grams. So that's 200 grams. Let's call that 200, that's 0.2 kilograms. So half of that is 0.1 kilogram. And times velocity squared. So that's 1/2 kx kv squared. Apply that. And now let's try something. I'm going to change what I've got displayed. I don't need that data table anymore. But let's put two graphs here. We can choose how many graphs we have. On this graph, I'm going to put, that should be labeled, fix it. That should properly be labeled potential energy. PE in joules. And this one should be kinetic energy. I think I've got, okay, whoops. I need that one. So I think we've got potential energy and kinetic energy. And interestingly, if you look at the number scales, they're pretty similar. And then we're probably going to run out of time, but we can do one more step, which is to make a total energy graph and see how that goes. I guess I'm a risk taker. Let's do that. We'll make one more new calculated column. Obviously, we're rushing through this, but we can take and make a column that's potential energy, column options. Let's see, I think I can, I forget how to do this one. How do I do adding the two columns? Let's see. I haven't done that one lately. Add calculate column, insert expression. Let's see, is there a B plus C? Well, we can do it with one of these, but I guess I'll just leave it go. Oh, one thing, important thing to stress here is the work I did here, Fran did not see, and that's the key. I got the data and then I blasted ahead and did some analysis, but that didn't happen for Fran. She has to do her own work, which she did, and probably better than me. But you can see her work on the right side. So we think that's a real key feature, that the teacher gets the data, the teacher can do the analysis, but that's not shared with the student who's got to do their own thing. Typically, I think the teacher would go through it once and show the idea and then leave the student to go with it. Fran, what would you like to add?
I don't particularly have anything to add. I happen to really like this experiment, and I love the capabilities that are in Graphical Analysis Pro. It's super easy if you wanted to add the potential and kinetic energy together to do a custom expression, which you're just adding the two columns, this column plus that column. Great stuff. Certainly, this is, our time is almost up here, but you can always send us questions at physics@vernier.com. We've got a chat link on our website, and you can also call us at 888-VERNIER. Usually our phones are open until 5 p.m. Pacific time, but we're actually having a company picnic today. Very exciting. So we're actually got the phones only open until 2 today.
Are there questions in the chat that we should handle right now?
So we do have a question that was, is the teacher able to see student work, or is it only one way? It is only one way. So in order to see student work, the student would have to save their work and send you the file, or they can paste their graphs and results into a document. I'm just going to go quick up here to export, which gives the opportunity to send out, on your graph. You can change the format, and you can save it as an image, or you can just copy it. The little icon here is for copy. And then you can save it, and they can pop it right into a Google Doc or their Word doc or whatever by using paste. So they would have to send it that way.
Any other questions there we should answer, because we are just about out of time?
I think that's it for questions.
Okay, well, I'm always available at Dave Vernier at vernier.com, and happy to talk to people. I've been doing it for a long time. I'd like to thank Angie and Fran again. And this is a nice couple introductory labs for your students. The second one gets a little complicated, but that's great, and you can take it as far as you want. So I think I'll wrap it up here now. And Angie, you want to say anything?
Just thank everybody for joining us today, and feel free to reach out if you have any questions. Fran or Dave or any of our physics team are happy to help you. So thanks again for joining us.